coming up, my friend, but when you're not so like a scene.
Good evening, everyone. Tell me, where did we stop in the last class?
Sir, concave and convex lens.
We had to start?
We started.
Okay, so did we draw any ray diagrams?
Like convex lens always.
Completed?
Yeah.
All cases for convex lens done? No? Which position you are doing?
So we had to start
convex and concave lens.
Convex is completed.
No. You should start convex and concave.
Show me what you are taking. Has it noted down? Yeah.
Yes, sir. This.
Okay, got it. We just introduced the definition of concave and convex. So, we have to start image formation by okay. So we will. So what do we need for image formation? How many rays? How many rays we consider for image formation? 2. Okay. Which 2 rays? One is
parallel to principal.
incident parallel to principal axis. What will happen to it?
It gets reflected.
After refraction, it will pass through focus. Okay, that's one. Which other ray?
And the other ray passes through focus.
So once it passes through focus, it will hit the lens, and after hitting the lens,
it will be parallel to principal.
It will be parallel to principal axis after refraction. Okay. Then one more ray which passes through optical center. So what happens to that?
Bounce back.
This is transparent medium, bounce back के लिए reflecting medium चाहिए. What medium is lens? It's a transparent, so it will transmit. So what happens when it passes through optical center?
It will pass through.
Yes, it will go straight, undeviated, because it is along the normal. Any ray which is hitting the optical center goes undeviated. Okay, this is the rule. So any 2 rays from this will take. Okay. So we have. So first object position is. What is the first object position? Yes, at infinity. Object at infinity. So when the object is at infinity, what is the nature of incident ray? Nature of incident ray is
parallel to the principal axis.
Parallel to principal axis. Nature of incident ray. Okay. So here how many points will mark? One is the optical center. Then center of curvature 1, principal focus 1, again principal focus 2, and center of curvature 2. So we'll mark 5 dots. One at the center of the lens, which is optical center. Then the 2 focuses, F1 and F2, and corresponding center of curvature. We had discussed this, right? We had discussed this.
No.
We did not discuss. Okay. So look how convex lens is made. We had not discussed it, right? There you go. So convex lens is actually made out of 2 solid spheres. So we have 2 solid spheres. So each sphere will have its own center. This is how convex lens is carved out of 2 solid spheres. Okay. And then the line passing through this, the center of the lens is called optical center. This line is called principal axis. So this is similar to what we did for mirror. Only difference is mirror, this was hollow sphere. Here it is solid sphere. Okay. So it has 2 center of curvatures. Lens has got 2 center of curvature because it has got 2 spherical surfaces. So for this spherical surface, this is the center of curvature. And for this spherical surface, it is here. And just like in the case of mirror, the midpoint of C1 and O is called F1. And this is F2. The midpoint. So lens has got 2 principal focus. Mirror has only 1. Only because it has got 2 spherical surfaces. Mirror has only 1. Okay. So now, so this is F1, this is F2, this is C1, this is C2. So when parallel ray is incident, take it till the middle of the lens. So what happens to the first ray? After refraction, it will pass through focus. Okay. Likewise, this incident ray will also pass through focus. So whenever the object is at infinity, the incident ray will be parallel to principal axis, and this is what we will get. So what is happening to the parallel ray? They are intersecting at focus. So this is also called converging lens. Convex lens is also called converging because it converges at focus, right? So or limit of converging lens. So this was the situation for object at infinity in case of concave mirror. Where is the image now? Image at, you'll say F2. What is the nature? What is the nature of image?
Real and point sized.
Real and inverted. First you write real and inverted. Then the size is point sized. Highly diminished or point sized. Or you can say highly diminished. So this is the region, since the parallel ray are converging at one point, concave or convex lens is also called as converging lens. So just like in case of mirror, everything, so it has aperture also. If I take this as AB, AB is the aperture, right? So it will have 2 focal lengths. I mean, focal length is this. This is focal length. F1. but focal length is taken as this length. For convex lens, focal length is taken as positive. Okay, not here. Wherever the parallel rays meet after refraction is focal length of the lens. Okay. Now, can I erase this item? What is the second object position?
Beyond here.
Yes. So this C1 can also be written as 2F1. Okay, C2 is 2F2. It is twice, it's midpoint, right? So instead of C1, we can also write 2F1. Okay. So the textbook is following 2F1, we also follow that. So object beyond F1. So first thing is draw the lens, draw the principal axis, mark center of curvature and focus on both sides. Then place the object. In this case, object is here. AB. First, take the ray parallel to principal axis. Will pass through focus. Then the second ray will pass through optical center. So you have one. So where is the image obtained? Between F2 and 2F2, right? So first image was at F2. So now the image is going away from F2. Okay? Just like in case of mirror, it was going away from F. So image between F2 and 2F. Obviously nature is real and inverted. And it is, what is it? Diminished. So the position of image position. Position, nature and size. These three things you have to write for all object position. Okay, so because any ray that passes through O will go undeviated. Okay? So with these two rays, you can draw almost all the ray diagrams. Next object position at at C1 or QF2. So where should be the image? QF1. Where should be the image? When the object is at C, where is the image? In case of mirror, at C only. So here where it should be? At 2 on the other side, right? So it should be at 2F2. Okay. Image at inverted and same size now. So exactly same nature and size as it was in case of concave mirror, right? So what are the changes? Where was the image forming in case of mirror? In the front side. Where it is forming? Behind. Okay. So the real image in this case is behind the lens. In case of mirror, where was the real image? In front of the lens. Correct? So that's the difference here. So only image position is shifting from front to back. But the nature is same for all the object position. But the lens is convex instead of concave. Object into F1 and F1. 2F1 and F1. Okay. So you have Now the image is here. And the object is here. And the image will be first it has to pass the focus. Second ray from O. So image we are getting beyond 2F2. So as the object is coming closer, image is going away and its size is increasing. Image is very- 5th position. Object at F1. So what should happen? The object is at F1. So it will be opposite of first case.
Adding.
At infinity. Image at infinity. Here I am inverted. What is the size?
Highly
Highly magnified. What was the 6th case?
magnified.
F1 and O. So you have to specify whether it is F1 or FO, right? What should be the nature of image?
Virtual.
Virtual, right? But all the real image is happening behind the lens. Virtual should be now in front of the lens, right? Let's check. So we have so this is now a diverging ray. B dash and B dash. Okay, so in front. So image is formed in front of lens. It is now virtual and upright. Magnified. We had discussed uses of concave mirrors and convex mirrors.
Yes, sir.
We had discussed. Okay, then, so you see all the image formation, position, as well as nature, as well as size for convex lenses very much similar as it was in case of image formation by concave mirror. So that's it. Only the image position is front, the real and virtual as swapped positions. So I hope no one has any doubt. Okay, let's go ahead. Now we'll complete the image formation by concave lens. Concave, or it is also called diverging lens. Okay. So now concave lens has two curvatures, just like convex lens. And it is, in this case, it is cut out of two solid spheres like this. Concave lens also has two center of curvatures. Okay, C1 can be written as 2F1. And this is So this has got only two object positions, object at infinity. So for infinity, the rays will be parallel. Now what should happen in this case? In case of convex lens, every parallel ray pass through focus. What will happen in this case? It will go away from focus. Away from focus, right? So this one. That's why its name is diverging lens. Okay, it goes away from focus. Likewise here, it goes away from focus. So then, when you extend it backwards, it meets at this is 2f1, this is f1. Okay, this is what it is. Shall I slow down? Have some water. Can somebody tell me why converging lens, convex lens is converging and why concave is diverging? But using
So because when convex lens is formed from the reflecting part of two convex mirrors.
reflecting part. Reflecting part. There is silver coating here. It is transparent, right? It is a transparent medium, not a reflecting medium. Because of its structure. So somebody should have asked. Anyway, let me tell you here. This ray diagram everybody had drawn, right? This one. So if you have a convex lens, actually it is you have to apply laws of refraction. We'll see just one ray, okay? That should give you the idea. Where will refraction take place? Whenever the medium changes, right? Correct. Let us say the first refraction should take place here. So it is entering from rarer to denser. So here the bending should be towards the normal. So where is the normal here? It is when you complete, the curvature is here, right? So this is a point of incidence. So for this surface, normal is here at 2f. Correct? Now, so if it goes straight, it will go like this. So it will now bend a little bit. It bent towards normal. It bent towards normal. So where is the normal for this point? This is the second surface. The normal is this.
Sir, the normal is perpendicular to the incident ray. Right? Like normal in refraction, the
Normal is the radius at the point of incidence. What is the radius here? What is the radius to this surface? This. This is a normal at the circular surface, not flat surface. That surface normal is perpendicular. So this is the point of incidence. Then you join the radius, right? Center of curvature.
yes.
Radius of curvature. So now here it is denser medium. Ray is traveling in the denser medium. So it is bending towards the normal. And now it will go away from the normal. The green. It's going away from the normal. So it is obeying laws of refraction everywhere. Understood? So that's why it is passing like this. So two refractions are taking place. But we don't show it. We just take it till here. Now that we know. Likewise, if it is a concave, so you have to know where are the normals, right? If the ray is incident parallel, so where is the normal in this case? The normal is this line. This is the point of incidence. This is the normal. So it is entering from rarer to denser medium, right? It should bend towards normal. So it will bend towards normal. Let's say here. First bending is here. Now this is the second point of incidence. So where is the normal here? So remember, on a circular surface, normal is the radius or it is a normal to the tangent at that point. Okay. So now it is entering from, it is leaving the denser medium, entering the rarer medium. So it will go away from the normal. Correct? It will further go away. It will go away such that, okay, when extended backward, when somebody sees from here, he feels that it is coming from F1. So this is the funda. Okay, this is exactly how it is happening. There is refraction taking place at surface 1 and then again at surface 2, according to the laws of refraction. Bends towards normal. When it is, so red one, it is bending towards the red normal. Rarer to denser. Green, denser to rarer, it's going away from the normal. It satisfies the laws of refraction. Clear? But when we draw the ray diagram, yes, now that we have understood it, we'll just draw it like this. We are not showing the refraction at this surface, at this surface. So average. Okay? Enter till the middle of the lens. Okay? That's how you draw. So what is the image position in this case?
At focus.
Which focus?
The F1.
F1. Okay, image at. So So since we are specifying the focus number, you don't have to specify in front of the lens or behind lens, because in the diagram we have shown where is f1. Okay. So now on the same side of object, when the image is formed, it has to be virtual. Right? Yes. So this is virtual. And this is point sized. Okay, next. So this is okay, this was just to tell you. If anybody is curious, can draw, otherwise not required actually. Second is, what is the second object position? Anywhere between infinity and O. Anywhere between infinity and O. O is called optical center. What was this thing called for mirror? P. Pole. Pole. Okay. This is optical center. So object between infinity and O. Let us say the object is here. Again, so one ray is going there, the other ray we are taking from O. Right. So this ray, the one which is diverging, when we extend it backwards, right? So it intersects it over here. Okay. So these two rays, right? This ray, these two rays appear to come from this point. So this is where we'll consider that the image is formed. Okay. Wherever this diverging rays appear to emerge from, so it is emerging from this point. Okay. So image between F1 and O. Virtual and error. Minus. Okay. So anybody has any questions on image formation by lenses? I think everybody is comfortable. So now we'll discuss sign convention. Sign convention. So just like mirrors, they have the same sign convention, but since the image position is different, so here the origin is optical center, all the distances to the left, so this is the principal axis, will be negative. All the distances to the right will be positive. All distances will have to measure from optical center, O. To the left, negative. To the right on the principal axis, positive. Then above principal axis will be positive. So object size, etc. Above principal axis positive. Below principal axis is negative. This is the sign convention. Similar to mirrors. Okay. But now due to the position of the real and virtual image, we'll see what happens now. So what about F? Focal length. What is the sign of focal length? Huh? So focal length is where the parallel rays converge. So for convex lens, it is on the right side.
So right side will be
So positive for convex lens. हाँ तो कितनी देर तक पॉजिटिव फॉर कॉन्वेक्स लेंस ठीक है एंड इसमें क्या था देखो यहाँ पे कन्वर्ज होता इट विल बी नेगेटिव फॉर कॉन्वेक्स
सर मिरर्स में ऑपोजिट केस
सेम केस सिर्फ इमेज डिस्टेंस उल्टा होगा बाकी सब कुछ सेम है
इमेज डिस्टेंस लेफ्ट
अभी जैसे रियल यहाँ बन रहा था इसमें कॉनकेव में ठीक है कॉन्वेक्स में रियल कहाँ बन रहा है दूसरे साइड तो वी पॉजिटिव हो जाएगा वी विल बी पॉजिटिव फॉर रियल लेंस के केस ठीक है अब देखो वी क्या होगा पॉजिटिव फॉर रियल नेगेटिव फॉर वर्चुअल इमेज ठीक है और यू क्या होगा यू क्या होना चाहिए हाँ
नेगेटिव फॉर रियल पॉजिटिव
यू हमेशा नेगेटिव ही होगा नेगेटिव ऑलवेज ठीक है नेगेटिव ऑलवेज So I think you have some session from our head office, so we'll stop in a while. Then what about image size? Object size. H is
negative
this
for
is image.
H is negative for real, positive for
D is image position. ठीक है object position. Where is B from O? Object position from O. Everything from O. So note all distances are measured from O. So this is object height, object size. So this is positive always, because object size is above principal axis, so along y-axis. What about image size? Yes. Positive for
Virtual, negative for real.
yes. Okay, then there is lens formula and magnification formula. Lens formula is one by f is equal to 1 by v minus 1 by u. And magnification formula is m is equal to h dash by h, and this is equal to v by u. No minus here. The sign यहाँ पे जो प्लस था वो माइनस हो गया, और वहाँ पे जो माइनस था वो प्लस हो गया, ठीक है? माइनस has become प्लस, तो साइन चेंज हुआ है खाली, बस इतना ही। तो अभी m का क्या होगा देखो, m is similar, m क्या होगा? वर्चुअल के लिए पॉजिटिव,
वर्चुअल के पॉजिटिव, नेगेटिव के लिए
रियल के लिए नेगेटिव। तो हमारा सिर्फ v का साइन चेंज हुआ और किसी चीज का साइन चेंज नहीं, इतना याद रखो, ठीक है? सो दिस इज पॉजिटिव फॉर वर्चुअल, नेगेटिव फॉर रियल, ठीक है? देन देयर इज पावर, एक ही टॉपिक बचता है पावर, दैट विल कवर इन द नेक्स्ट क्लास।
सर इस चैप्टर के बाद इलेक्ट्रिसिटी शुरू करेंगे।
इसके बाद कौन सा है? उसमें रीमेन आई है, तो यू लेट मी नो इफ majority of you wants electricity, I will go with electricity, ठीक है? तो ऐसा करेंगे, okay? All of you want electricity after this chapter?
Yes, sir. Yes.
But that is still 2 weeks away, at least 2 classes away, because lots of numericals are.
So are the topics like this?
What is it? Yes. Next one, or now also you can ask.
So I don't have the next one.
I have the rest.
So I don't understand what is variable resistance. How does variable resistance work?
Resistance basically limits the current in the circuit. Okay. Right now, this is variable resistance. So when I am increasing the speed of the fan, I am reducing the resistance. One speed is slowest. Right now, maximum resistance in the circuit. Now if I increase, resistance is reduced. This is variable resistance. Resistance is opposition to the current. It's like friction. What is friction? Okay, friction controls speed. The opposite is the motion. Just like that, current also has to be controlled. So I said unlimited current into a device. It may destroy the device. Yes, I need to regulate the current now. To regulate, so this is a regulator. Regulator has different values of resistance. So I vary the resistance to limit the current as per my requirement. I mean, I can't just let the full current flow. Right. So it's very simple, don't worry. We'll start.
class.